Hi everyone, let's take a look at another stoichiometry problem. Okay, so in this problem it says for the reaction between hydrogen and bromine, which produces hydrogen bromide, how many grams of hydrogen bromide will be formed if 5.6 liters of hydrogen gas, H2, reacts completely with bromine, Br2? Now, just like before, we want to start by making the balanced chemical equation, and they're telling you you have hydrogen gas, H2, reacting with bromine, Br2, and you're forming HBr. Okay, so they already gave you the formulas here, so all you need to do is balance this, and you have two hydrogens on the left, two bromines on the right, two bromines on the left, one of each on the right. We just put a 2 in front of here, and now we have our balanced chemical equation, so we're ready to go on. Now, we're starting off with 5.6 liters of hydrogen gas. And the assumption in this problem, unless I tell you otherwise, is that the gas is at standard temperature and pressure. Okay? And remember, if a gas is at standard temperature and pressure, 1 mole of any gas at standard temperature and pressure is 22.4 liters. We learned that last semester. So they're giving you liters. Our first step is to balance the chemical equation. Our second step is to take whatever they give us and convert it to moles. So we're starting off with 5.6 liters of hydrogen gas, and we need to change this to moles of hydrogen gas. And because it's at STP, we know 1 mole of hydrogen is 22.4 liters of hydrogen. All right, so first step, balance the equation. Second step, take whatever they give you, whether it's grams or liters or whatever, and change it into moles. Third step is to put in your mole ratio. And the mole ratio comes from the balanced chemical equation. Now they're asking us to find out how many grams of hydrogen bromide. So that means we need to put moles of hydrogen bromide at the top of our mole ratio because we want hydrogen bromide in some form in our final answer. We want to get rid of moles of hydrogen. So here's our mole ratio. And now we fill in the numbers which come from the coefficients in the balanced chemical equation. The coefficient in front of H2 gas is 1, and the coefficient in front of hydrogen bromide is 2. All right, so we're almost there. Now, the last step, in this problem, they're asking us how many grams of hydrogen bromide will be formed. So we have to take our moles of hydrogen bromide, and we have to turn them into grams of hydrogen bromide. So I'm going to put grams of hydrogen bromide up top and moles of hydrogen bromide on the bottom. So now, before we can do this, we need to figure out the molar mass of hydrogen bromide. So hydrogen bromide has 1 hydrogen, and it has 1 bromine. If you look on the periodic table, hydrogen has an atomic mass of 1.008. Bromine has an atomic mass of 79.904. And since there's only 1 of each in hydrogen bromide, it's pretty easy calculation. Just add them up, and you get 80.912 grams per mole. So we're going to take this number, put it up here, 80.912 grams. All right, let's see what we can cancel out. So it's always good to check your units and see what cancels out. It helps you see if you set the problem up correctly. So liters of hydrogen cancel, moles of hydrogen cancel, and moles of hydrogen bromide cancel. And what you're left with is grams of hydrogen bromide, which, ta-da, that's what we want. So let's take our calculator. You go 5.6 times 2 times 80.912, then divide that by 22.4. And put that in your calculators. And when I do that, I ended up with 40.46 grams of hydrogen bromide. Now, let's take a second. That's a 40.46. Let's talk about sig figs. Remember those? How many sig figs are in 5.6? That's right, just 2. So how many sig figs should be in our answer? Just 2. So it is 40 with a decimal point after the 0 to get our 2 sig figs. The sig figs on this are a little bit tricky. If you round this to 2 sig figs, rounding it, you get 40, 40, right? Because 40.46 is 40. But if you wrote 40 this way, 40, with no decimal point after the 0, that would only have 1 sig fig. The 0 at the end only becomes significant if you have a decimal point after it. So the correct answer, if you're worried about sig figs, would be 40.6. Alrighty, so I hope that makes sense. Just to review, step number 1, balance chemical equation. Step number 2, take what they gave you and turn it into moles. Step number 3, do your mole ratio. And step number 4, turn it into whatever units they want your final answer in. Alright, hope that helps. Have a great day, you guys. Bye.